Welcome! I'm happy to see all of you here because we can't take that for granted. Because I guess most of you registered on the NDC Security webpage and then you paid. And to do that, oops, clicker is not working. To do that, you likely, sorry. Let's try to start it again. Good start. I just had a blue screen of death 5 minutes ago. So we will, there we go. So you might remember this from registering and paying. The check-in service that NDC is using. Some years ago, a friend of mine was an event administrator of an event on check-in. And check-in had just redone their entire web page. And he realized that he could add any other check-in user to his event as an event administrator. And then in case they had registered something wrong, he could change their details, like their email address. What if he had found an NDC event administrator and changed their email address to his own? He could hijack that user. What if he found the NDC account administrator and changed the bank account number for payouts? There might not have been an NDC Security. So it's things like that I'm going to talk about today. My name is Halvor Sakshaug. I'm the application security lead at Forsta. You may not have heard about Forsta. It's a quite new name. It's a merger of multiple companies. One of them is Confirmit, which was a Norwegian software company that I worked for 11 years. Started as a developer, then moved into security full-time. So I do scanning, I do some hacking, I build some tools, run scanners, yeah. And also talk about security, teach security. Today I'm going to talk about broken access control. And it's pretty much like this door. You might see what's wrong. This is discrimination against people who can walk stairs but can't climb. And this is the way a lot of applications are. If you just try to find your way around the obstacles or the authorization checks, you will. But you know what's really wrong here? You can't see it. The door isn't locked. And that's, of course, also how a lot of applications are. If you just do something which is not kind of what you are allowed to in the UI, if you just kind of start changing something and testing some other requests, you're suddenly allowed to bypass things. So broken access control is on the OWASP top 10 list. Does anyone know which position it is in? In the first. That's right, because this is like the SQL injection of 2023. It's not just one thing, it's a lot of different things. Like this list is all of them, so it doesn't continue below the screen. This is all, it's just 34 different things. So go tell the developers, this is what you need to care about to cover the first item on the OWASP top 10 list. I'm going to focus on something called IDOR, or Insecure Direct Object Reference. Someone tried to change to another term, BOLA, Broken Object Level Authorization. It is the same thing. So what is authorization? Because we're going to talk about authorization quite a bit. So authorization is the function of specifying access rights or privileges to resources. If you go a little further down, during operation, the system uses the access control rules to decide whether access requests from authenticated consumers shall be approved or disapproved. Now, this is the theory. In practice, it doesn't happen all the time as it should. Sometimes it's completely forgotten. That's luckily very few times. Sometimes it's just here and there, but My experience is that it's very common for an application to have an authorization flaw somewhere. Now, is it a good thing for a speaker to read straight from Wikipedia? Well, I've tried to define authorization before and being sloppy in the definition. One time I held that speech, one of the authorities on the subject, oooooh, was in the audience and quickly corrected me. So that's a speaker tip. So when you're about something, you might end up with a path like this in the address line. And are you ever tempted to change it? Yes, me too. I'm also tempted to change it when I see something like this, because I know that if I change this and I can see someone else's order, then they can see mine. It works both ways. And I'm not very fond of people being able to see what I bought, how much I paid, or anything like that. And also, if I go to see my profile and I see something like this, see like users 542. And then I think, why aren't they using current user? Why do they need to expose my user ID? And I might be tempted to change this one as well. And here, now this is the solution if you want to do some basic broken access control testing. The solution is to do +1, 542 to 543. That's the entire foundation of this type of testing. And I can promise you that if you do that in a lot of places, you're likely going to find something interesting. I think you get the picture. So sometimes we can do that in the browser. Just change the address bar. It's really simple. Just flip a number. A 5-year-old can do it. Yes, even my 5-year-old can do it. And I actually do have a 5-year-old. Sometimes it's not that easy. Sometimes it's a request that you don't see, like it's be sent from the browser, like behind the scenes. It's not in like a URL that you can change in the browser. Then you just attach a web proxy. So you're basically man-in-the-middling yourself. And this web proxy is like a pit stop for requests. You stop a request, you change something, you pass it on to the server. You can even change things on the way back, but here, the important thing here is that you change the request. You change something. For instance, an ID, like a number. It's the simplest part. Okay, not legal advice. Are you allowed to change the URL? Yeah, there have been people threatened with court cases for changing a URL. Are you allowed to view the source of a web page? Same thing there. All that, they retracted that, or they never made it to court. So yeah, the best thing, of course, is to have permission to test on your own system, not test on other systems. So to actually give some legal advice, don't script. If you find something, don't make a script to download all the data. Don't even make a script to estimate how long it would take to download all the data. And don't do it on a competitor. So, real-world example. Some years ago, one of my colleagues wanted to go on a cabin trip. And he said, in my area, all the good cabins are on this system. They're not on Airbnb. They are on the system that has a really crappy web page. It's really old, or it seems old, the UI is terrible, it's just terrible. I bet you it has security vulnerabilities. The subject of the email he sent me was hack request. This site is still online. We tried to report stuff to the owner. They didn't really understand the word vulnerability. So I'm not going to tell you which site it is. But the path was pretty much like this. So this was the only thing he sent me, like the URL to his cabin contract. So it would tell me and him like which cabin, and of course all the cabins would be publicly listed on this webpage, but it would tell me when he had booked this cabin. It would tell me his name and his phone number and his home address, his email address, and also the name and age of everyone going on this cabin trip, including pets. So what's the problem here? I guess you already guessed it, because, well, how much can you change here and still get something interesting? Well, you can change the number. So I tried a few other numbers. One thing I forgot to say about the legal advice, do the +1 and then you stop. Don't try every single number. Once you kind of establish that you get to data you shouldn't see, stop there. Don't go on. If you get some data that you think you might be able to see, okay, test a few more until you establish if you can see data you definitely shouldn't. I tried some higher numbers and some lower numbers, and well, I could see past and future bookings, random people, random cabins. What's the problem with that? Well, this is in Europe, it was pre-GDPR, or it's no longer pre-GDPR. So there was a lot of personal information in there. Another thing is, it says when you're going to be at this cabin, also the number of vehicles, of course. So in case someone wants to break into your home, they know when you're gone and when your guard dog is also gone, which is convenient for them. Another real-world example, I wasn't involved, neither in this nor what followed. So this is the January 6th insurgency, and the service in question was Parler. Not that much used or well-known here. It's a right-wing Trump supporter social media. A lot of the people storming the Congress 2 years ago used Parler, posted a lot of stuff from the event on Parler. And right after, there were rumors of Parler being hacked. And I remember some of those rumors, and they were like, yeah, I think some SMS-based two-factor authentication has been breached. No. It was an IDOR. They just found some ID, and they could just iterate through all the posts from Parler. So they scraped the data and posted it online. Like they said, more than 99% of the data from Parler. But you think that that's the data that was there, but that was all the data. That was also the deleted posts. So people who thought after this that, ooh, this is a failed coup, let's go delete. Well, the data was still there. Data wasn't deleted. Data was still accessible, and it was scraped. And in addition to that, of course, images and videos included geolocation. This was used in the second impeachment of Donald Trump. It's likely still being used in court cases today. So when you hear about a hack, we often think it's some like black magic hacking. They started with social engineering, then they chained 3 different vulnerabilities to attain remote code execution. No, it's often so much simpler. You remember the users 542? What if you can see other users and maybe even change other users? What if you just start at the beginning? User number 1. Who's user number 1 typically? The admin. And if you get control of the admin account, what can you do? It's more of a question, what can you not do? So I've been a developer, and I've been working on a few systems, some of them from the very beginning, some where I've come in later. And I've seen that we often struggle with authorization. But when we start out, it's really easy. We typically start out with something really simple, solving some problem we have. So we start out with 1 object type and 1 user type and maybe an administrator. And it's not complex at all. It's possible to do authorization, kind of get all the rules in place. It works. And it doesn't matter if we add more objects, add more users, because the rules work. The problem is, of course, as time goes by and complexity grows, because we need to change, adapt our systems. We need to be attractive to cater for the demands of new clients or old clients. So we create another object type, which of course has some implicit rules that if you have access to one object, you'll also have access to this one. Or we start to group users. in like groups of friends or in companies or some other way. And they, by definition, should share some things. They should not share other things. As you understand, complexity grows. And it keeps growing. New requests come in. Short timelines. We push out a new feature, even more complex relationships between the objects. Another user level, because sales wanted to license another user or cheaper user so they could sell more. But of course, this one needs a different permissioning system. So we need to introduce that. So complexity grows and grows. And then what happens? Mergers and acquisitions. Suddenly, we have to reconcile two systems in a record time. And we already know that our authorization system isn't very good. But now we're into trouble, because these two systems can't easily be aligned. They have done this or solved authorization in two completely different ways, and now we need them to work together in a record time. So that's the time we kind of pretty much just give up. We know that we should do this better, but we just kind of, yeah, it's good enough. Hope nobody finds out. So that's when we need to start testing. And my favorite thing to test is actually for IDORs. It's a bit boring, but it's quite fun when you find something. So how does kind of a system look when we start testing these things? Okay, so we have a system with Alice and Bob. They have two different accounts. They need to authenticate. Alice creates a few objects. They're only for her to see. And Bob also creates an object, and he wants to share this with Alice and gives her a read permission. Now, turns out that Alice doesn't only have the read permission. She can also update this object. Why? Well, maybe the code was complex, and someone didn't realize that when they changed something, they didn't only give the read permission, they accidentally also gave the update permission through a code change. Bob creates a few other objects, like the blue one and the green one. And the blue one, or any blue object, Alice can delete. How come? Well, they were in a rush to push out the functionality for the blue objects. Delete was the last thing to be implemented. They were going to fix this later. Yeah, you know, that's one of the lies we tell ourselves. The green object, she has full access. She can do anything. I'll come back to why in a minute. Charlie is with a different tenant, like another company. He has some objects. Supposedly, they should be totally separate from other companies because you shouldn't be able to see data from a competitor. But Alice can still read, can see his object, one of them at least. And why is that? Well, maybe someone had to make some functionality for sales or for support or services, so they didn't have to kind of change their user to be in a different company to help their clients with their problems. They could start to see objects cross-company, but it wasn't restricted to just support or services. The green object, what's the problem? Why can Alice see it? Well, anyone on the internet can see it, because it doesn't even require authentication. Does this happen? Well, if you go and look at my NDC talk from 2017, I found something like this. There was a system used by probably 50,000 Norwegians, plus minus 10 to 20,000, where you could go and look at the user details. And it was open to anyone. You could just do the different IDs. And you could see the name and the home address, phone numbers, email addresses, and I think there was a few other things, which was bad. But probably the worst thing was that the same applied to the change password function. So you could just take the user ID you just learned on the other page, and you could change the password, and it did not require the existing password. So you could set a new password on any user and hijack their account. So it does happen. So to do the authorization checks, we introduce very often permissions. So we can give permissions that, like, say that someone can see my object, or someone can update my object, or even delete it. But we also have to remember that this is also something we need to have the correct access control on. If you want to set permissions, you typically need to set at least 3 things. Which object are you giving permission to? Which permission are you giving? And which user are you giving this permission to? So the object, if you can give permission to any object, you're just kind of doing this hacking, making this hacking just a little bit harder. Because an attacker can't just go directly to your object. They'll first need to go to the permissions and add permissions for themselves. Then they can get to whatever data is there. If you don't restrict the permission correctly, well, then I could go here and I could change from read-only to write or administrate. And the last one, can I give permission to any user? Can't I? Well, maybe I shouldn't be able to. And I found a few instances like this where you're only supposed to be able to give permissions to people in your own company. But it turns out you can give it to anyone. Isn't that fine? Well, there are some problems with this. And first one is that you need to populate this table. So you need at least some name and some user ID and a company name. And that typically will come from the API. And often, it's not just that, it's often a lot more coming from the API. And it could be things like this. It could be like the user ID, the username, and the email address, company ID, company name. And this is quite interesting if you start to learn about all the different users. You need to learn about the different companies, all the other people who use this system. Now, can you find all your competitors' users? Okay, you learn how many of them are using the system. Maybe you can search for their email address. Maybe find a breached password. And maybe they even reused it, and now we can log in as them. Or maybe you can just lock all of them out at once. What's in your logs? If you have someone, a hacker, looking for an IDOR, your logs will probably tell you a lot about that they hit permission denied again and again and again, until they succeeded. At that point, your log looks perfectly normal. There is no errors. There is like 200 OK in your access log. There is no like 401 or 403 or 404 or whatever you choose to tell in that instance. There is nothing there. It's indistinguishable from legitimate traffic. So we need to test. We need to find out ourselves if we have IDORs. And to do that, we need to send requests to test it, if we kind of do it in a manual way. And let's say that we have one object and we have an API where we have these verbs. And if we're going to test this, we need to test all the different verbs, and even hidden options might give us some interesting information, even though it doesn't give us a lot. And we might also need to create sensible payloads for a lot of these requests. But just for this one object with this one endpoint, that's 6 requests. And let's say that we have multiple user types. I'll use the word user type here. That could be different roles or different types of users, different permissioning. And if we're going to repeat this for all the different user types, well, 6 times 3, we're up to 18 requests. But we should perhaps also repeat these for users in another company to check that we aren't leaking information across companies. So that then we double it. We're up to 36 requests to test. And what if this object also have another more limited API endpoint? Now we're up to 50 manual tests just for this one object. And if you have a lot of objects, you have several hundred tests to do, which is kind of infeasible. Doesn't really scale. And then there are some other vectors. You don't need to repeat all the requests with all of these, but you can. These are some other IDOR techniques that I found on Twitter from someone called Mufadal. What about changing the request content type? What about supplying the same parameter multiple times with the same or with different values? Or what about putting the ID in an array? This could bypass things. So I've seen a lot of IDORs. I've found a lot of IDORs, and I've been working as a developer, so I can see this from various places, and also I've been working with security test tools and penetration tests. So I want to kind of give a picture of why this is happening and why we are too optimistic and why we're not, or how we're not doing the job. So I'll start on top here with product managers, and product managers are very different. Their role and their job is very different. Some of them actually define the product. And a lot of them use user stories, like this one. As a user, I want to update my profile so that I can change my information. Probably seen things like this. What you might not have seen is kind of something like this. As a user, I don't want anyone else to access my profile so that they can see, modify, or delete my information. Anyone seen this? No. Very few people have seen anything like this, because what happens if you have this? It's not anyone else. Probably need a third one for, as an administrator, I need to access and be able to modify all profiles. So it's a lot of specification that we actually need to do. So we're too optimistic. Product managers, they only write the positive user stories, and they pretty much leave it for others to decide. Of course, developers are used to this. So developers will then, sometimes, they will sit down, discuss what the rules should be, and they will document it. And then they will start implementing it. But a lot of times they will just start implementing and make up the rules as they go. And they might even write tests. And they'll write tests like this to start out. User can see, user can update, user can delete, administrator has full access. Still only the positive, happy cases. So what they should do, and some do, is to write something like unauthenticated is not authorized. And user in different company can't see, can't modify, can't delete. But they also do some functional testing in the browser. With the administrator user, of course, or with only one user. But this is not complete test coverage. Yeah. If the developers actually document it and not expect it to be changed next week anyway, then the testers might get some ideas on what they should test. But what do testers do? Well, I think we all know from this joke. A QA engineer walks into a bar. She orders 2 beers, orders 0 beers, orders -1 beers, orders a lizard, orders a null pointer, tries to leave without paying. Satisfied, she declares the bar ready for business. The first customer comes in and asks where the bathroom is. The bar explodes. Now, as developers, we think that this is really outside the box. We only expected positive numbers, non-negative positive numbers. And this is what we get, strings, negative numbers. Don't people understand our UI? Now, this is not outside the box. This is more outside the box. Change the unit price to 1 cent. Change the currency to Zimbabwe dollars. order with another customer ID. Load the order verification with another order ID. Maybe the order is ready to pick up and you can do it. Try to access /admin. Maybe it's accessible. Why not try to send it as HTTP 1.0 to see what happens? Well, it hasn't been necessary for the last 15 years. Order from another origin, just to see what happens then. Because then the bar explodes. So testers often, if they do it at all, if they test at all, or if they test something, they're not testing the really crazy cases. And they're very often not testing broken access control. And they're also lacking the knowledge and the tools to do so. So you can ask your tester, what do you use to test for broken access control? And there aren't many answers, really, that are good. So I'll come back to some of them later. And you can also ask them, do you use a web proxy? If they're not using any kind of web proxy, they're likely not testing for broken access control. Or they do it like with their hands tied on their back, at least. It's very impractical to not use a web proxy or another tool. So speaking of tools, security test tools. Your boss or your boss's boss spent a lot of money on security test tools. And those who sold them say that, yeah, use this tool. They'll fix OWASP top 10 or find OWASP top 10 problems. They'll be PCI DSS compliant, and yeah, they will find all these different types of vulnerabilities. They will never, ever find an IDOR. They will not find broken access control of that type I'm showing here, because that needs human intervention. It needs to have the rules defined, you need to verify the outcome. So a fully automated tool cannot find this. So you need to put some human effort into it. But you did. You had a penetration test. You paid a lot of money for that as well. That didn't show it. And that could be your fault, or it could be the penetration tester's fault. And if you set up a test server, created a user, created some data, and gave the credentials to the tester, it's your fault. Because then you made it extremely hard to find IDORs. While if you had created multiple users of different user types and in different tenants or companies or whatever segregation there is in your system, if any, create data for all of them, and then hand all the credentials to the tester. Then the tester will be able to log in as one user, see the objects available to that one, log in as another one, and then try to access the objects from another user. Then it's possible and kind of fairly easy to try to find IDORs. But does that help? I've done that every single time I've had a penetration test done. And I also lately specifically asked the tester to look for authorization vulnerabilities. Have they given me any findings? No. Have I found stuff myself? Yes. Because the penetration testers, they really like to just fill the report with output from automated tools, because that's easy. They also run some kind of scripts like login, change password, try to find something there. Because looking for IDORs is boring, it's laborious work. It's much easier to find some other items to put in the report. How did we get here? Let me ask you some questions and raise your hand. Who has, in their studies, had a mandatory application security course? Not many. Okay, next question. Who has been trained in application security by their current or a former employer? Yeah, this is a filtered group. So this result is quite good. Who has been trained at any time, studies or later, in avoiding or detecting broken access control? Oh, not bad. As I said, it's a filtered population. So I've been trained. I've taken this course by SANS, which is giving certifications and education in security. The web app penetration and testing and ethical hacking. So it was 6 days of course. And we learned about a lot of different tools and techniques and vulnerabilities and writing reports and OSINT and a lot of different things. Packed days. Did they teach us what the 5-year-old can do? You guessed the answer. No, they did not. And I gave them feedback, but it seems like the curriculum for the course is still the same. It's much more fun to use some tools than to actually do the nitty-gritty work of changing requests and testing stuff that way. So what should you do? If you're sitting here with this uneasy feeling that we're just doing this kind of pat down, we don't really check the details because we don't dare to do it. And if you have that feeling, then go back. And when you're back at work tomorrow, maybe, then do some random samples and check if the state is really bad. And if it's bad or really bad, then try to speak to your manager and say, well, I think we really need to look into this and we need to improve our authorization because it seems like we have some broken access control. What should a tester do apart from ordering beer? Tester should get some tools, like a web proxy. I like Fiddler, and I'll just come back to Fiddler on the next slide, but burpsuit is a security testing tool that I think at least one tester, each company should have access to. It's not that expensive. It has an extension called Authorize, which is perfect for authorization testing. Who would have guessed with that name? With Authorize, you log into your application as typically a low-privileged user. And you just take whatever authentication tokens there are, like a cookie or an authorization header, and then you give it to Authorize. And then you're going to close that browser, start another one, and you log in as a high-privileged user, like an administrator. And then when you start Authorize, for every request that you issue as the administrator or a high-privileged user, Authorize will repeat the request. Once for the user you provided, and once for an unauthenticated user. And then it will give you this color coding of all the responses that it will get and compare it to what the administrator user that you are actually browsing with is getting. And it will tell you like, yeah, seems like it's bypassed. Could be because it's a public resource. Could be that you're actually lacking access control. Or it could say that, well, it seems to be enforced. You get a 401, or it's the response length is 0, or it doesn't really know. So you'll have to inspect manually. And this is what I mean by it needs human intervention. It needs someone to look at these cases. Is it a public resource? Is it okay due to something? So if you don't have burpsuit, you can also do this with Fiddler. I've created a script that you can get on this page. You also find that host or URL in the last slide. And something I called automated additional authorization testing with Fiddler script. So I'm using the Juice Shop. Cecilia here had a talk about Juice Shop yesterday. See if I have Fiddler and Juice Shop. Now I need to, oh, sorry, I'll get them over. I had the blue screen, as I said, right before I started, but I managed to hopefully get all this set up. Now we'll see if I really managed. So we have Juice Shop here. Okay, let's try to make Fiddler, give it some more space here. even more. Okay, and we'll just remove that. And of course, it has to restart. Try to make it a little bigger for you to see. Okay, there we go. Maybe I'll make this even bigger. So, okay, now we're ready. So what we'll do first is to harvest users, because we need, just like with authorize, this is pretty much the same thing, except that we can have an unlimited amount of users. Authorize only can take one authenticated users. Here we can have many, and here you can also modify the scripts as you like. So the first thing we will do is to go and harvest authentication tokens. And then I will go to the app. I'll click on account. Click on my account. And then Fiddler asks me, because it found a user. It says that, well, this is a user without any authorization header. So that's likely an unauthenticated user. So I'll call this one unauthenticated just for simplicity. Okay. Try to go back here. Well, I was expecting one more user. Now I can see it somewhere. There it is. Yeah, so this is the authenticated user, and this is in the incognito window. So I'll just call this one incognito. Whatever. Might be a mistake there, but that's okay. Now we have harvested two users, the unauthenticated and the authenticated user. Now we stop harvesting users. And we can log in a different user. Okay, and you also need to drag that one over. We'll split screen. Okay, we'll log in. There we go. So now we're logged in to Juice Shop with this user that we're gonna kind of be issuing the request with. And Juice Shop is designed to be a vulnerable web application. So it's like you can play and try to find different things. I guess you can also try to fix the vulnerabilities there as an exercise. Very good thing about Juice Shop is that it's very visual when you find something. So now I'm going to change something here in Fiddler again. This is from the script saying additional authorization requests. So the first thing I will do is to click on add to basket. So this user adds the apple juice to the basket. Ooh, we got the confetti cannon because we found a vulnerability in the system. And if we look at Fiddler, we see that this is the original user, the one issuing the request, added something to the basket, got a 200. The unauthenticated user and the incognito user got a 401. So that seemed to be okay. But down here, looking at the shopping basket, the original user got a 200. The unauthenticated user got a 401, while the one in the incognito window got a 200. So here we can see that, well, this is likely something which is not good. And of course, this one even says that you successfully solved a challenge. View basket. View another user's shopping basket. Also provoked an error message. This request here, it's just likely just a public resource. Okay, one more example. So we have reviews in Juice Shop. We can review different items. So we can say something about this one. Yeah, maybe it's too sour. Ooh, confetti cannon. What happens? Well, let's give Fiddler the full screen. Can't click when I'm looking at an angle. Okay, what does the request look like? Can't I see the raw? Oh, maybe the best. No, isn't it that one? No, that's this one. Review. So the request is just like the author. You can specify any user. It doesn't have to be yourself. And a message. So all three users send this one. And they're all accepted because you all see they come, or no, sorry, it's here. They all get the 201. And if you see here, there are 3 reviews made from that one request where Fiddler duplicated it. What should you do as a developer? If you look at the code, it could be like this. You have some method where actually most of it is authorization. And this authorization is tangled into all the other application logic. And the problem with this one is that this function has the same name as like the function we're calling at the bottom. And it's very easy in this case to just forget to call this method that actually does the authorization. So we might just forget about it. But let's look at the rules. I've seen things like this. So you want to see a report, and you can see the report if the report and the user are in the same company, and if your role is viewer or designer. Then you can see the report. That's a sensible rule. You can see the report if you're an administrator. Then you can see all reports. Or you can see the report if you have specific permissions in the database. Fair enough. But this is not how we should do it. We should not have like the authorization logic right here with all the other code. We should try to move it out to a different class or a different service that can do the authorization. Why? Well, it's reusable, and it's also a lot easier to test with unit tests. But we shouldn't really stop here. We should move it all the way out of the logic in this method. We should, if the language allows, use authorization attribute. Because we could even say that all functions like this, like get and put and post and delete, must have an authorization attribute. And if we could even make checks on that so we don't compile if some of them are missing. And if we don't need authorization, we can have a no authorization attribute. And then you could also use Open Policy Agent or OSO to take care of authorization. There was a very good talk yesterday about Open Policy Agent. And if you've done what I just said, you already have the tests in place. So when you swap in Open Policy Agent, you can just run the same test and see if your rules they have for Open Policy Agent are the same as the one you already had. And you might need to change something, or might realize that your rules have always been wrong. What else should a developer do? You should write automated tests. No, you should not. That may come as a surprise. You should make an automated test framework. Some of my colleagues have done this. I really like this project. So they take as input all the endpoints, and they get them from Swagger or OpenAPI definition. And then they also insert in the fixture all the different user types. So they can test every endpoint for every user type and for every verb. So this is kind of the simple part. You might have to kind of do the nitty-gritty details of adding all the correct payloads. But kind of this is quite simple, actually. It's not hard to build this framework. It's not very many lines of code. And then you can output something. Like they use Excel, it's fairly readable by both man and machine, where you get all the rules from the system. And then you can take this and you can give it to the product manager and say, are these rules correct? These are the current rules as they are enforced in the system. Are they correct? And you can join into the discussion. Is this how we want this to work, or is it not? And you might find out, you might have some surprises, and you might want to change something. And then you can feed that file back into the system, because that's now how the rules, that's how it should be. And if you change something, well, the test will fail until you make the corresponding change in the rules. If you add another endpoint, tests will fail. If you make a change that actually changes something in the authorization, well, tests will fail. It's a super safeguard. And if you have a lot of code or like different applications which has pretty much the same users or user types, this is actually a very good way to do a lot of testing, because it will run, as you see here, it will run very many tests in a very short time. And you will really find out if you have broken access control. So, have we solved the problem if you do this? We have at least solved a lot of the easy cases that are most easily found. But of course, there are more advanced ones, which I won't cover, like when you have multiple items to authorize at once, or when there's like extra parameters that will do something that you don't normally see. I actually found one like this where I could add role ID and suddenly I could become the administrator. Well, that wasn't meant to discourage you, but because I want just you to know that these are things you can do. IDORs are everywhere. Go find them and stay secure. Thank you. Any questions? Yes.
Are there legitimate reasons for having a user ID in the URL?
So the question is there legitimate reasons for having a user ID in a URL? Not many. Like the case I gave where look at your own profile, use current user. Don't flag the user IDs, because showing predictable IDs is not a very good thing to do. There might, of course, be cases, but yeah, maybe you shouldn't have it in the URL. If you can avoid it, keep them out.
Public profiles?
Yeah, if it's public, there's a whole set of different rules should apply.
Doesn't mean it has to be a predictable predictable ID.
No. Yes.
What about using GUIDs in URLs for lots of stuff? I know one system that heavily uses it. I just read the RFC, which says it's not the most secure thing.
So the question is, what about GUIDs? They are a lot better, but they're somebody wrote something that they're not always good. There are some problems with GUIDs, or the main problem is often Google. If things are cached or or indexed, because that's something you can do if the request URLs are indexed by Google or other browser or other search engines. It might be possible to find GUIDs, and GUIDs are not fully random, like secure random. They are pseudo-random. So it's really hard to guess GUIDs. They don't have like the full bit strength because they're also like time-based and they have some other information. So they're not like super strong, but if you just want randomness, so they're not easily guessed, GUIDs are a lot better than having like sequential numeric IDs starting in like 1, 2, 3, 4. You come a long way with a GUID. Other questions? Okay, thank you.